To week 15 of Geology 234, Intro to Remote Sensing. Today we're going to be performing our first supervised classification. So to begin, let's go to week 15 homepage and scroll all the way down to the activities section. And we're going to download the required data. So I'll click that and it'll take me to another page where I will select download. And this is going to download a zipped compressed file. As you see here, it popped up, it's already downloaded. And so then I want to extract those files. So I'm going to go to my Files Explorer, go to Downloads, and you can see it's at the top there. There's a little zipper, which means it's compressed and zipped. Right click, Extract All. And let's put it in its own folder. So I already created a week 15 folder on my desktop, and I'm just going to set it in another folder within the week 15 called Lab. Okay, so it's going to be in the Lab week 15 folder. Select folder, extract. And while this is extracting, we can hop over to ArcGIS Pro and start a blank ArcPro project. My blank ArcPro project started, and I'm going to connect to that folder that I just created. And it was in a week 15 folder that I made on my desktop and lab. So I'll select OK. And then it should have the downloaded extracted data, which it does. Great. So the first thing we want to do is open up the data folder in the catalog pane. And let's right-click on Portland NAIP subset, the .tif, and let's click Properties. We're going to check out our raster layer. We want to see how many bands there are, let's see the data that we're working with. So let's go down, scroll down to where it says Band Metadata. And how many bands does this raster have? Well, your answer should be 4. So you could see that by looking at band metadata. And then what is the raster resolution? So to find that, you can look at the spatial reference, and then it says linear unit 1 meter. So your answer should be 1 meter. Okay, so the raster data looks good. And if we had a 30-meter raster data, that would be a lot harder or more challenging to classify because it wouldn't be as distinct of boundaries, visually speaking. Okay, so click OK, and so we'll exit out of the Properties pane. And in the Contents pane, let's add this to a map. So right-click on Portland, the TIFF layer, add to New at the very top, and then select Map. And a new map should pop up. That could take a minute because it's kind of a large file. Okay, so what we have here is a small clipping of an image in Portland. And so you are a GIS analyst, and you're asked by a city planner what the land use category types are within the city. And he is asking because he wants to see the developmental growth of the city within the last 5 years. So we're just going to do part of the analysis, which is a supervised classification for a snapshot of today's imagery and categories. Okay, so let's select Portland NAIP subset, and then let's go to right-click and select Symbology. And we want to change the symbology RGB type. So we've done this in class before weeks ago. And we want to change it so that the vegetation is more obvious. It'll pop so we can, that can help with classifications. So instead of a 1, 2, 3 combo type, we're going to do a 4, 1, 2. So change the red category to band 4, the green category to band 1, and the blue category to band 2. Okay, and so your results should look like mine, where now the green vegetation is like a deep red, and it's more obvious to our naked eye. So this is called a false color composite as a reminder and review. So it shows healthy vegetation as the red, and you will use this band combination to improve the image classification results. Okay, so we can exit out of the symbology pane, and then let's add more data. So within the data folder, in the catalog pane, let's add the training sample layer. So that is actually called, right click on training samples symbolize.lyrx. It's a layer file. Oops. And choose add to current map. It's at the top. Okay, so this is a training sample that was already created for you for the purpose of today's lab. But if you were to do this for like your semester project or for a different project, you can make your own training samples. And all it is making points or polygons and labeling those with a number. So let me zoom in here. For example, I made these polygons and then I labeled them as 1. So they all got a value of 1. And then I classified 1 as being concrete. And so that's all it is. It's as simple as that. But today, this data is provided for you. So there's 9 classes here, and each class represents a spectrally distinct and unique set of pixels. There are classes to represent dark areas of soil and light, and also represent roofs of different colors. But remember, today's objective is to just categorize developed areas versus non-developed areas. So that's why I really wanted to emphasize the vegetation. And so how would you characterize the pixels within the polygon? And so the answer would be the pixels within the polygons are spectrally similar, right? So this concrete is going to be spectrally different than the forested vegetation. Okay, so now we have looked at our data and it looks good, and now it's time to classify using the supervised classification technique. So let's click on the TIFF file, our raster set data set. Go up to raster layer at the top, the ribbon. Oh, I'm sorry, nope, go to imagery. Sometimes I even forget, even though I use this program all the time. And then we're gonna select classification wizard. And we used this last week, so this should be somewhat of a reminder of where to find this. So classification wizard. Oh, and yours probably starts out different because I was using this earlier, but we're going to select supervised at the top. We don't want object-based, we want pixel-based. I'm going to make this a little bigger. Pixel-based. For some reason, I didn't see pixel-based. I just kind of clicked out of the window over in the contents pane and clicked back in, and then it was there. So if that happens to you, that's a solution. And then we need the classification schema. So click the drop-down arrow right next to the manila envelope, and then select generate from training samples. So that means the classification schema is going to be generated from our training samples that we made, well, that you were provided. And so it's that one. It's called starting training samples within the data folder, and select OK. And then and then we also need the output location. So let's put this one in our output folder that was created for us. I want to see what I'm calling it so I remember. And it's just called output. Okay. And then optional is for training samples, choose starting training samples. And you may get this error at the top. You could just press the X. And actually, let's keep all the optionals blank. If you get an error, let's go through and redo it. So let's do supervised, pixel-based, classification schema, oops, generate from training samples, select OK, and then we selected our output location. And then you can select this, starting training samples. So if you got that error like I did, just go through and redo the parameters. I think this is a bug in the data. Okay, so select next. And so the next panel here is Training Samples Manager. And in this pane, you can examine the number of samples and the pixel percentage. So how many of the pixels are covered within this category versus trees versus soils, etc., all down here. So my question for you is, which class has the highest percentage of pixels, right? And so you would reference this table, and it would be, the answer would be grass. There's 29.86% of the pixels are categorized as grass. And then inversely, which class has the lowest percentage of pixels? Well, you go to the bottom, and the answer would be dark soil at 0.46%. Okay, let's select next because we're just going to keep the default. The next step is train. So this is where we train the model by using our data that we delineated and started out with. And for today's exercise, we're going to use the maximum likelihood right there. At the top, perform a maximum likelihood classification. Okay, and then select run. And so you're gonna see this wizard run and preview a raster, which is gonna be created in the contents pane. And mine already popped up. And so it's called preview _ classified. And then so right click on that layer and select zoom to layer. And let's unselect Portland from underneath. Okay, and so this is the preview of our classification wizard's output. And so you could see the different classifications. We have brown roof, white roof, red roof versus grass and trees. But let's, so we turned off the visibility of the Portland raster data. Let's also turn off starting training samples so we don't see those. And then click on this so it's highlighted and go up to raster layer ribbon. And in the effects group, let's slide this to 40%, about 40. We're just gonna take a look at the output. And so if we zoom in to the big U-shaped building in the center, let's do that now. Actually, I'm gonna go a little less. It actually helps if you do imagery base map. So I'm gonna add that as well. So I go to the map ribbon, and then I'll add imagery base map. You can kind of see this U-shaped building better. So I'm going to zoom in there. And let's take a look at our output. So this is telling us that and if you don't know, you can click on it. So this is saying it's a white roof. Okay, and then the green over here is trees. So maybe that's true. But then in here, let's click in this area that should be the parking lot. It's being classified as brown roof. So is that correct? The answer is no. So like we discussed in the lecture, the classifiers aren't perfect and they do make mistakes. So that's why it's really important to go through your output and check. And that is also why one of the steps in the wizard is a reclassifier, because you get the opportunity to reclassify these. But for today's lab and objective, this is fine because we just want to know developed versus not developed. But I'm just emphasizing the fact that it's not perfect and sometimes you do need to go and reclassify. Okay, so let's go back to the image classification wizard and let's select next. And now this next step is to actually classify. And so for the output classified dataset type, or for the dataset type prelim, I'm gonna highlight all that by selecting Control A, and then type prelim sup, just one P, just like how I'm doing. Oops. And then output.tiff, okay. And then output classifier definition file, we're gonna type sup output final, just like that. And then select run. And so now it's running the results. Oops, got a pop up. Ignore that. It's running the results, and then you're going to see that the classified output is added to the contents pane. So let's uncheck our preview, and then zoom to the new output by right-clicking on prelim sub-output, zoom to layer. So now it's even more distinct than the preview, and you could see the different classifications really well. Okay, so back to the image classification wizard. Let's select next. The next step is merge classes. For classification schemas with subclasses, you can use this step to merge the classes. Because you are using a custom classification schema for today that does not include subclasses, you're going to skip this step completely. So let's just select next. And now we're at the step that I mentioned called reclassifier. And so you can change individual pixels that have been misclassified, like we saw in the parking lot in front of the big U-shaped building, in this step normally. But the confused classes in this analysis do not affect the objective for today's lab because you will not make any changes, because you will not see any changes in developed versus not developed areas. So that's why we're actually just going to skip the reclassifier option and then just select run. Okay, and then select finish. Once you hit finish, you'll close the image classification wizard pane, and now you have a thematic classified raster that you've created, and you're ready to provide the results about the growth of this developed areas to the planners at the city. So good job making your first supervised classification. I know I went through that quickly, but feel free to pause and rewatch some of the tutorial or reach out with any questions. But yeah, you can take a look at the attribute table. It should have the values for each, the class values for each classification. And you can do further statistics on this as well. But for today's lab, all you need to do is create a map showing this output and the class names, and with including your 5 essential map elements. So good job, and see you next week.